So for today's video, we're going to discuss about the number systems.
So we're going to show you a conversion from binary, decimal, octal, and hexadecimal.
So first, let me corresponds to 15. And these are all the 16 numbers in hexadecimal. So we have the example 101101111. So first, ato ni sila i-group by 4. So datay upat ka bits 1, 2, 4, and 8. So sa first group, ang atong i-add is kanirang 8, 2, and 1. So 8 plus 2, 10 plus 1, 11. Then sa second group ang atong i-add is kaning 4, 2, and 1. So 4 plus 2, 6 plus 1, 7. Then ang kaning 11 is atong siya i-convert into hexadecimal value, which is ang 11 is nag-correspond siya sa kuan B. So ang atong answer diri is B7 with a base 16.
So next, I'm going to show you the conversion from decimal to binary, and then to octal, and then to hexadecimal. So first, I'm going to show you the conversion from decimal to binary. So for example, we have here 75. Always remember that decimal is a base 10, have base 10. So we're going to put 10 here to indicate that it is a binary decimal number. So there are two ways to convert decimal to binary. I'm going to show you the first way. So we're going to use the power of 2. 1, 2, 4, 8, 16, 32, 64, and 1 to 8. We're going to stop from 1 to 8 since 1 to 8 exceeds from 74. So this power of 2 is basically we're going to just do times or multiply this number 1 by 2. So 1 times 2 equals 2, then 2 times 2 equals 4, and so on and so forth. So next is we're going to find here the highest number that is below 75, and that is number 64. So we're going to 75, we're going to subtract 75 by 64. So 75 minus 64 is equal to 11. So next is, we're going to find now the highest number but less than 8. So that with less than 11. So that is 8. So 11 minus 8, that is equal to 3. So we're going to do the same with 3. So we're going to find the highest number but less than 3. So that is 2. So 2 minus 3 minus 2, that is equal to 1. So here we're going to add these numbers. So 64 plus 8, and then plus 2, and then plus 1. We're going to stop here in 1 because if we total these numbers, 64 plus 8, that is 72. 72 plus 2, that is 74. And then 74 plus 1, that is 7. Here it is remainder 1. So next is 35. We're going to 35. Zero, 0, 1, 0, 1, and then 1. So that is the binary conversion, decimal conversion to binary. So the next conversion is from decimal to octal. So always remember that decimal is a base of 10, and then octal is a base of 8. So for example, we have 394 base of 10, and then we're going to convert it to octal. So we're going to use the division method. So since octal is base of 8, so we're going to divide 394 divided by 8. So 394 divided by 8 is equal to 49.25. So 49, we're going to find the remainder value. We're going to multiply this 25 by 8. So 0.25 multiplied by 8 is equal to 2. So next is, we're going to copy this, 49 divided by 8. And then 49 divided by 8 is 6.125. So we're going to do the same. 6 remainder. So 0.125 times 8 is equal to 1. So remainder 1. So next is 6 divided by 8. So that is 0. So the 79 divided by 16 is equal to 29.9375. So 29, and then remainder, we're going to multiply this 9,375 by 16. So the answer is 15. So next is 29 divided by 16. 1.8125. One, and then remainder, we're going to multiply this 8,125 by 16. The answer is 13. So we're going to put 1 divided by 16. And then, since we cannot divide 1 by 16, we're going to put 0. So 0, and then remainder 1. So to find the hexadecimal value, we're going to start from the most significant value up to the least significant value. So 1, 13, and 15. So here, we're going to use this table to find the hexadecimal value. So we're going to find 1, which is 1. So 1. And then 13, we're going to find 13. And then the hexadecimal value is D. So D. And then 15. And then the hexadecimal value is F. So we're going to put the base 16. So the hexadecimal value of the 479 decimal is 1 DF.
Next is octal. So I'm going to show you the conversion of octal to binary and decimal. So for example, we have a 35. So we all know that the octal have a 8 base. Convert to binary. So the binary have a 2 base. So first, let's separate the 3 and 5, and we're gonna use a 1, 2, 4, and 1, 2, 4. So I use 4 and 1 because 4 plus 1 is equals 5. Then I use 2 and 1 because 2 plus 1 is the sum of 3. Then next, I'm going to put a 1 because I use this, then 0 because I not use that. 1, 1, 1, and 0. So this is the final answer for binary. Then it's okay to not include this 0 in your final answer. So let's put in this. 1, 1, 1, 0, 1. So this is the final answer for conversion the binary. So this is an example for octal and binary conversion. So next is octal to decimal. For example, you have 35 and convert to decimal. The decimal is 10. So let's arrow. So copy the 5, copy the 3, then multiply to the base of octal, which is 8. So bukunat tas power of 8 power of 0 and 8 power of 1. So is equals. So 5 times 1 is equals to 5 because any power of 0 is equivalent to 1. For example, 8, 0, 8, 1, 8, 2, 8, 3. Then 8, 0 is any raise of 0 is equivalent of 1. Then 8 power of 1 is equals to 8. 8 power of 2 is equals to 64. 8 power of 3 is equals to 512, so on and so forth. So 5 times 8 power of 0 is equals to 5. 3 times 8 is equals to 24. So let's get a sum of this. 5 plus 24 is equals to 29. So this is the conversion for octal to decimal.
So next is the decimal, so it is base 8. So equals to, we're going to find the hexadecimal value of these octal values. So since it is hexadecimal, we're going to put base 16. So first, before we convert this octal value into hexadecimal, we're going to convert it first to binary. So to convert this value, we're going to use the binary computation. So we're going to start from 1 to 4. We use these numbers since it is octal. So what we're going to do is add these numbers that will equal to 7. So 4 plus 2 is equal to 6 plus 1 equal to 7. So since we use all these numbers, so we're going to put 1. So 1, 1, 1. So next is 0. So 4. So since we didn't use these numbers, so we're going to put
So in this binary value, we're going to group this into 3. So 1, 0, 1, 0, 1, 1, 0, 0. So 1, 2, 3, 1, 2, 3, and let's put 0 here. So next, we'll 1, 2, 3, 1, 2, 3, 1, 2, 3. So let's put 3 here because 3 is the only one that has 1 value in binary. And the second set is 1 and 2. So 3 plus 1 equals 4. Then here is 2 has the only one that has 1. So bring down the 2. So this is the octal value. So yeah, 2, 4, 3 base